Welcome back, everybody. Today we're going to explore geometric sequences. Before we start geometric sequences, let's look at a sequence we've explored earlier this year. So, find the common difference of each sequence. So we go 1, 3, 5, 7. So what are they adding each time? They're adding 2 each time, and now it says use inductive reasoning to find the next 2 numbers in the sequence. So we can keep this going. And we get 9 and 11. Let's look at our next sequence. We have 19, 17, 15, 13. So it is going down, so I know that my common difference will be a negative number. My common difference is negative 2, and my next 2 terms are 11 and 9. So if you remember, what is this called? And it's called arithmetic sequence. So when you add or subtract, it's arithmetic. Today, we're going to do geometric. And I bet you've already figured out what it means. So if you multiply or divide, but technically we'll multiply. If you multiply, it's called geometric. Alright, on this slide we need to find the common ratio for each sequence. We also need to find the next 3 terms. So we start at 3 and they multiply and then we get negative 15. So I know that if I multiply 3 by negative 5, I will get negative 15. Let's see if that continues to work. I'm going to multiply negative 15 by negative 5, and that does work. So my common ratio is negative 5. Now I need to find the next 3 terms. What I did was I multiplied negative 375 by negative 5, and my answer was 1,875. So to continue this pattern, I need to use that common ratio and keep multiplying by negative 5. And here's what I get. So here are my next 2 answers, and notice that this one is negative because I did a negative multiplied to a positive, but this will be positive because I had 2 negatives multiplying. Okay, this time we notice our number getting smaller. We start with 3, and now we have 3 halves, and then we have 3 fourths and 3 eighths. So what is our common ratio? And if you look, they're multiplying by 1/2 because 1 multiplied to 3 is 3 and 1 multiplied to 2 is 2. We end up with 3 halves. So each time they're multiplying by a half. 2 multiplied to 2 is 4. Then they continue. 4 multiplied to 2 is 8. So the common ratio here is 1/2. Let's find our next 3 terms. If we keep multiplying by a half, which means we're multiplying the denominator by 2. 2 multiplied to 8 is 16, and it continues. 1 over 32 and 1 over 64. So this number is shrinking even though we are multiplying. Just like arithmetic sequences, geometric sequences do have a shortcut or a formula, and this is it right here. So if we know the first term and we know the common ratio, we can find any term we want using this formula. And it's spelled out pretty easily. The first term will go here, and the common ratio, which we found on the last slide, goes here, and then this is going to be our exponent. It will be the term we want minus 1. And remember why that is. The reason we always minus 1 is because we have the first term in the formula already. So it says find the first, fifth, and 10th term or terms for the sequence that has this rule. So here's our rule. Negative 3, and they're going to multiply it by 2 each time. Here's what we have. Our first term is negative 3 because the first term is written right after the equal sign. So negative 3 is our first term. So A1, our first term, is going to be negative 3 multiplied to 2 to the first power. And now watch what happens when we do this. 1 minus 1 is 0, and if you remember, 2 to the 0 power is really 1. And so what do I get if I do 1 multiplied to negative 3? My first term is negative 3, and that makes sense. If they're multiplying by 2 each time, my second term is going to be negative 6. Okay, my third term will be negative 12. So what I'm going to do is find my fifth term, and here's the work for it. I have my first term. My first term is negative 3, and then I multiply it to 2, the common ratio, so I'm right here. And then I want the fifth term, so that's n. 5 will represent n. I'm going to take that and put it right here in the equation. So 5 minus 1 is 4, and it looks like this. Okay. Next, I'm going to do my exponents first. So 2 to the 4th power. That equals 16. Next, I'll do negative 3 multiplied to 16. My answer is negative 48. So if you think about it, the fifth term, so if you do this pattern 5 times, this is what you'll get on the fifth time. Let's try the 10th term. Once again, I set up my formula. Negative 3 is my first term, 2 is my common ratio, and then I'm looking for the 10th term, so I do have to minus 1 because the first term's already included in the formula. So let's simplify. I end up with negative 3 multiplied to 2 to the 9th power, so I need to find out what 2 to the 9th power is. That's 512. Here's what I come up with. The 10th term, and this is how I write it, a to the 10th, equals negative 1,536. Let's look at a word problem using geometric sequences. Suppose you drop a tennis ball from a height of 2 meters. On each bounce, the ball reaches a height that is 75% of its previous height. Write a rule for the height the ball reaches on each bounce. In centimeters, that's important, what height will the ball reach on its third bounce? And we're going to talk about the difference between bounce and dropping it. So, what does A equal? And then it says, hint, meters or centimeters. Great point. The question wants to know centimeters, but it started off with meters. So first step, let's take 2 meters and make it centimeters. 2 meters does equal 200 centimeters, so that will come in handy. Our common ratio, well, it says that it reaches a height of 75%, so we're multiplying by 75%, which is 3/4. Please write that in with me. So that's 3/4. Next, we have to find what term number we're looking for, and this is going to be a little tricky. We want the height of the ball on the third bounce. So if we look, the initial drop is 1, but the drop doesn't count the bounce. Okay, so really if we want the third bounce, if you look here, we're looking for the 4th drop. Okay, so n's going to have to equal 4. That's what we need to use to find this. So next, let's write a rule to find the height of this ball on the third bounce. Once again, even though I'm looking for the third bounce, I do have to, it would be the 4th drop that would provide the third bounce. So I did write A of 4, and this represents the third bounce. And my first term is 200 because it starts at a height of 200 centimeters. So next I'm going to take my common ratio, and my common ratio will be 3/4. And for my exponent, I'm going to do the 4th drop minus 1. And that actually gives me 3 for the third bounce. So now all I have to do is use a calculator and answer the question. So I'm going to do 0.75, 3/4, to the third power, 4 minus 1, and multiply that to 200. Here's what I get. What I get when I multiply is 84 centimeters, 84.375 centimeters. So it started off at 200 centimeters, and after 4 drops in the third bounce, it's only at a height of 84. Here are the practice problems. First, you're asked to find the common ratio and the next 3 terms. So what are they multiplying by? And if it's shrinking, it will be a fraction that they're multiplying by. Next, they're going to ask you to look at the sequence, the pattern, and determine, are they adding or subtracting, and that would be arithmetic, or are they multiplying or dividing, and that would be geometric. So you need to look and decide which is which and then circle the appropriate answer. On these practice problems, I want you to use the formula that's printed here. So this is the first term, this is the common ratio, and find the first, fourth, and eighth term for each one of these. You may use a calculator, but please write it out. All right, take care and bring any questions you have to class next time we meet.